In previous videos, we talked about and demoed the deep object pattern. Today we are looking at another important pattern of the decentralized space. dFun, the decentralized and deep function. When do you call a function decentralized? When it can be used by anyone, by any developer, by any project. But I also said that dFun can stand for deep function. For a decentralized function to be useful, we need to know about it, to have it registered in a system and easily found by developers. And we are using the Ethereum Data Service EDS system to create such a service where you can have multiple points of entry to access functions at any depth level. We can have many smart contracts, each containing thousands of functions. And we made a system to link these contracts with one another, unidirectional or bidirectional. And this way you can call a function from EDS contract 2 by sending the call to EDS contract 1. Because EDS contract 2 has received a unique ID and has been registered with EDS contract 1. So EDS contract 1 acts as a proxy for other contracts or as a subsystem root. And you can have multiple subsystems with different roots. So you can have other EDS contracts registered under the proxy, each with their own functions. What we see here in this demo is an EDS proxy or root contract. Each contract has a documentation attached for each function, and part of this information lives on-chain, which is the minimum information about the function and its inputs and outputs, and part off-chain on a decentralized storage system referenced by this IPFS hash. This EDS contract has an ID of 5 and lives at this Ethereum address. And these are the functions that it exposes, from key 0 to key 12, 13 functions linked to EDS ID 5. Next, we see several more functions that belong to EDS ID 2. And indeed, a smart contract called Basis is registered with EDS ID 2. So we can run any of these functions. By clicking on them, we get a form built from the on-chain information about the functions, inputs and outputs, and their types. But let's call the rebase function. The rebase function from the basis contract. In a previous video, we already demoed the basis contract and how you can transform from one base to another. We used this dApp made specifically for interacting with the basis contract. So we have 10001 transformed from base 2 to base 10, and it is 17. 100011 is 35 in base 10. So what we are going to do here is call the exact same operation that we did earlier, but this time we call the basis contract through the proxy. Here we don't have the encoding done for us by the app, so from base key 0 will reference base 2, and from base key 2 will reference base 10. These are actually the indexes in which they have been introduced in the system. Base 2 is at index 0 and base 10 is at index 2, being the third element. And 10001 in ASCII code is 31, 30, 30, 30, 31. We make the call and we get the answer 3137, which is the equivalent of writing 17. We add another 1 here, so another 31 ASCII code, submit, and we get 3335, which is the equivalent of 35. So we've used the proxy contract to call the basis contract, but we can do the call directly. This is the page where we can see the contract with EDS ID 2, the basis contract, and look at its functions and registered contracts. So now we go to the rebase function and we can make the same call directly. What we have achieved is a network of functions where the execution is forwarded in a transparent manner. Pure functions called from off-chain tools are the best use case for this system, and gas costs are lowered to a minimum. The records themselves are upgradable and flexible, so you can have decentralized management of systems and subsystems. And functions have synergy. When a member adds a dFun, all other participant members benefit, multiplying the goodness. And of course, these contracts have all the other advantages of EDS.